Hello, doctor. My name is Vanilla Subramaniam. My metric number is CE210213. I'm from Analog Section 1 and Group 1. Let's see the introduction. Frequency response of a given frequency dependent circuit can be displayed as a graphical sketch of magnitude against frequency. The horizontal frequency axis is usually plotted on a logarithmic scale while the vertical axis, representing the voltage output or gain, is usually drawn as a linear scale in decimal divisions. The main distinction between a BJT and a FET is that a BJT allows both majority and minority charge carries to flow, whereas a FET only allows majority charge carries to flow. The voltage gain of amplifier is a function of input signal which is dependent on its magnitude and frequency.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Muhammad Asri. Matrix number DE 2032 from Group 1, Section 1, Analog Electronic. So for group assignment, we are given this circuit. Okay. Given this information, and these are the tips of this question. Okay, first of all, we need to find we need to determine GM node and voltage gain. First of all, this is RG1 and RG2. We need to find RG total. Okay, so this one is parallel. So RG1 parallel with RG2 equal to 99.09 kilo ohm. Okay, for step 1, input KVL loops. Since VRG minus VGS minus VRS equal to 0. Okay, since IG equivalent to 0, so VRG equal to 0. So bring VRS to right side. So VGS equal to minus VRS. Negative VRS equal to negative ISRS. And since IS equal to ID, so ISRS equal to IDRS, negative IDRS. Okay, so we make a simple table. Since IDSS equal to 8 milliamp, so this is 8 milliamp. So the value of VGS equal to 0. Okay, so we bring 8 milliamp into this equation and times RS. Our RS given is 1.2 kilo. So the answer is negative 9.6 kilo. Okay, so for step 2, okay, ID equal to IDSS times 1 minus VGS over VP square. Okay, so this is the simplest table we can get, where A is IDSS, this is IDSS over 2, this is IDSS over 4, and 0. Also, this is the value of VP over 2, and 0.3 VP, and this is 0. Okay, so from graph, okay, we can look at graph. Okay, this is the point 0 to 8. This one, 0 to 8. Okay. This is the plot graph for this table. Okay, the intersection point Q point is for VGSQ is negative 1.55 volt, and IDQ equal to 3.1 amp. Okay, so from graph we can get VGSQ and IDQ. To find VDS, let KVL equation in output. So VDD minus VRD minus VDS minus VRS equal to 0. VDS equal to VDD minus VRD minus VRS because we want to find VDS. Okay, so VDD equal to IDRS. Okay, so VDD equal to IDQ RD plus RS. Okay, so we plug in the value, all the value, and VDS we got negative 18.27 kilovolt. Okay, so for circuit analysis, this is our circuit analysis. So since RD equal to infinity, so RD is not included in AC analysis. Okay, so the N equal to RG, same with RG. This is RG. Sorry for mislabeling. So this is RG, 99.09 kilo. So this is Z out equal to RD equal to 4.7 kilo. Okay. So next we find AV. So the equation for AV is V out over V in. So V out equal to negative GM VGS RD parallel with RL over V in VGS. Okay. So we cut VGS and what we got is negative GM times RD parallel with RL. Okay, so we need to find GM first. So GM, the equation for GM is 2 IDSS over VP, positive side VP. So 1 minus VGSQ over VP. So we plug in all the value. It should be the bracket here. Okay, so the GM value is 2.45 S. The unit of GM is Siemens. So GM node is 2 IDSS over VP. So the answer for GM node is negative 4. Okay, so we plug in the 2.45 in this equation and we got AV equal to negative 7.833K. Okay, next, cut-off frequency. Okay, cut-off frequency 1 over 2 pi CR and 1 over 2 pi CR. Same. The difference is this one RG plus RC. This one R total RD parallel with RL. Okay, this one capacitor 0.5 micro. This one 1 micro. Okay, so we got 1.459 hertz. This one is 99.57 hertz. Okay, so C, we need to find CG, CC, and CS. For CG, the equation is FLG equal to 1 over 2 pi RC plus RI CG, where RI equal to RG. So we plug in the value, and CG, what we got is 1.459. Then for CC, 1 over 2 pi RO plus RL, RO plus RL equal to RO, where RO equal to RD parallel with RD. Since RD equal to infinity, so the answer is infinity. So CS FLS equal to 1 over 2 pi REQ CS, where REQ equal to RS parallel with 1 over GM. So the REQ value equal to 0.141. So plug in the value, and CS, what we got is 513.072. Okay, that's all from our group. Thank you. Assalamualaikum.
Let's see about the discussion. An analog circuit works with analog signals, which is the full signal is a continuously variable signal in the form of a wave has more data in it. This is because it is a continuous wave as opposed to digitalized waveform that is made up of binary ups and downs, which we may call as pulse down. We live in an analog world. All the waves in the electromagnetic spectrum are analog. Furthermore, since the way we hear and see things is a continuous wave, an analog circuit makes an electronic representation of our physical world. Analog circuits are used in many communications devices and being debated now are questions of whether the analog has significant performance advantages over digital for some applications. The example of the applications are microphones, amplifiers, um, heartbeat rates, detector, and thermometers.